In the last tutorial, we looked at the relationship between whether someone's above or below the federal poverty line and whether they visited the doctor in the past 12 months. Now we're going to go ahead and add gender to our model, allowing for separate odds ratios by gender and allowing for an odds ratio that's interpretable conditional on gender. First, we're going to state our model. The outcome for our model is yi, and it's defined as either 1 or 0. It's 1 if the subject visited the doctor in the past 12 months and 0 otherwise. The first covariate is again the poverty level covariate indicator. It's equal to 1 if the individual is above the poverty level and 0 if they're below the federal poverty level. Now we're adding in an additional covariate, x2i. And this guy is equal to 1 if the person is female and 0 if they are male. So these are the covariates in our model. Again, we're going to model yi using a Bernoulli distribution with probability of success pi, and then we model pi on the Logit scale. And since I'm assuming no effect modification of the relationship of poverty and visiting the doctor by gender, I don't throw in an interaction term yet. So for now, this is my logistic regression model. Let's go ahead and fit that in Stata. Before fitting the model, we first need to generate some covariates. As in the previous tutorial, we need to generate NOPOV, which is equal to 1 minus poverty. It's an indicator of whether someone is above the federal poverty line. Next, this is a good trick for when you're coding things. We have this variable gender, but we don't know whether someone is male or female. If we browse in the data set, I can see that females have the value of 2, males have the value of 1. So that makes things kind of weird. It would be a lot easier if I just generated a covariate called female that's equal to 1 if someone is female. To construct such a covariate in this case, I just need to take gender and subtract 1. So now if I say table gender and female, I see that female is defined as 1 when someone is female, and it's defined as 0 when someone is male. So it's really easy if you have it named female. Intuitively, it should be equal to 1 when someone is female. So this is a good coding trick to always know how your variables are coded when you fit your regression models. Now we'll go ahead and fit the logistic regression model. We can either use the logit command on the command line, or we can go statistics, binary outcomes, logistic regression. Our dependent variable is doctor. Our independent variable is NOPOV and female. And hit OK. So our fitted logistic regression model is logit pi is equal to alpha, which is negative 0.03, plus beta 1 times x1 plus beta 2 times x2. This model makes a pretty strong assumption, though. It assumes that the odds ratio for whether someone visited the doctor, depending on whether they're above or below the poverty line, it assumes that that odds ratio conditional on gender is the same for both males and females. So you're assuming the odds ratio is constant within gender. We should also consider a model that allows for effect modification by gender. So now we consider a model with effect modification. It says the logit of pi is equal to a constant plus beta 1 x1, beta 2 x2, plus beta 3 times the product of x1 and x2. And what that's going to do is it's going to give us gender-specific odds ratios. So the first thing I need to do is generate that interaction term. And I'm going to say generate interaction equals NOPOV times female. And now I'm going to fit that same logistic regression model, but I'm going to add in the covariate interaction. So now in this regression model, I have my estimate of alpha, I have beta 1, beta 2, and beta 3. To test for evidence of effect modification, I simply need to test the null hypothesis that beta 3 is equal to 0 versus the alternative that beta 3 is not equal to 0. So I want to test the null hypothesis that beta 3 equals 0 versus the alternative hypothesis that beta 3 is not equal to 0. This is a test for no effect modification by gender, or that the odds ratio for visiting the doctor for those above and below the poverty line is constant within gender when I condition on gender. To do this test, I just need to look at the output for beta 3. I find a coefficient estimate with a standard error. This leads to a z-statistic that's equal to 0.1. And under the null hypothesis, z follows a normal distribution with mean 0 and variance 1. So it follows a standard normal distribution. This leads to a p-value of 0.91 or 0.92. Consequently, there's no evidence of effect modification. We have no evidence that the odds ratio of visiting the doctor for those above and below the poverty line varies by gender. Now, if you think back a few weeks, what we've done here is we've tested for no effect modification, no interaction. This is very similar to the Mantel-Hansel test. Recall that the Mantel-Hansel test allowed us to test for no effect modification by categorical covariates. So we can do this same thing within the construct of the logistic regression model. So now I have no evidence of effect modification by gender. Let's see if there's evidence of confounding by gender in this model. Let's go back to the original logistic regression model that we fit at the beginning of this tutorial with no interaction term. I found an estimate of beta 1, my log odds ratio, that was approximately 1.0. If I fit the model from the previous tutorial that did not account for gender, I found an estimate of the log odds ratio that was 0.67. So without gender, I found a log odds ratio of 0.67. My conditional odds ratio when I include gender was 1.0. So I see a big change in this odds ratio. And when I add a covariate into a regression model and I see a big change in my odds ratio, this tells me that there is evidence of confounding by gender in this scenario. Further, if I fit a logistic regression model and I looked at the relationship between no POV and female, I find that there is a negative association between female and no POV and that this is statistically significant. So it appears that females are more likely to be in poverty. So gender is associated with poverty level. We've already seen in week 7 and before, we know that I can also just fit a logistic regression model and show you this, that females are much more likely to go to the doctor. So I have that gender is related to my covariate, poverty, and gender is related to my outcome. So it is a confounder, and we see this when we compare the logistic regression model without gender to the logistic regression model with gender.